continue the question. Now your classroom workbook question number 4. Sorry, I think it is question number 6. Question number 6. Now again here also the flat is given. Now we'll first see this flat. Now by considering the following Bode plot and all the poles and zeros are real, and he is asking to find the difference between FH minus FL. Okay, by considering all the poles and zeros are assumed to be real, and he is asking FH minus FL. Now see here. Now first we will take this line. Now this is X log FL comma X comma Y here is 0. Next this one X is log 300 comma Y X comma 0 X comma Y here is 40 and the slope is given. So change in y-axis 40 minus 0 by change in x-axis log 300 minus log FL, which is equal to plus 40 dB per decay. Therefore 40 cancel. Log 300 by FL, which is equal to log 300 by FL, which is equal to 1, which is 300 by FL, which is equal to 10 power 1. So FL, which is equal to 30 hertz. FL, which is equal to 30 hertz. Now if you see here, this is log 900 comma 0, and this is, now for this line, now this is the line, this line you have to be considered. Okay, log FH comma 0, this is X comma Y. Now here if you take here, this is X log 900 base 10 log 900 base 10 comma, now this is X and Y is 40. Now this is the point, X is logarithmic, and this is the point where Y is 40. Therefore if you find for that now change in x-axis by change in y-axis 0 minus 40 x1 y1 x2 y2 y2 minus y1 by x2 minus x1 log fh base 10 minus log 900 base 10, which is equal to minus 40 dB per decay. Now which is nothing but minus minus cancel, log fh base 10 minus log 900 base 10, which is equal to 1. Log fh by 900, which is equal to 10 power 1. Sorry, 1. So fh by 900, which is equal to 10 power 1. So fh, which is equal to 9000 hertz. Now this is FL, this is FH. What he is asking? He is asking the difference between FH minus FL. So therefore FH minus FL, 9000 minus 30, which is equal to 8970 hertz, the difference between FH minus FL. This is question number 6, note down. Now this is classroom workbook question number 7. All these are the previous GATE examination questions only. Most of the problems what we are solved in the classroom workbook handout questions are most of the previous GATE and IES and other different competitive examination questions. Okay. So this is the question number 7. What is question number 7 is, now he is giving a Bode magnitude plot as well as a Bode phase plot. He is given Bode magnitude plot and Bode phase plot. Now he is giving this question. See, in this question magnitude plot is given and phase plot is also given, but the slope of the lines and all these things are not given, but options are given. Okay, we'll try to concentrate on the option such that you can easily evaluate the question. K into 1 plus s whole square by s plus 100, k into s plus 1 whole square by s plus 100 whole square, k into s minus 1 whole square by s plus 100 whole square, k into s plus 1 by s plus 100. These are the four options which is given to you. Okay. Now see here, no slopes, nothing is not given, but we have to catch one simple point here. Now this is the corner frequencies we have to be assumed. This is the corner frequency. Slope is changing from one level to another level. That particular frequency is nothing but obviously corner frequency. If you observe, now 0 degrees will change to 180 degrees. 0 degrees will change to 180 degrees means how much is added? 0 is changed to plus 180 degrees means plus 180 degrees is added. Plus 180 degrees is because of, yes, the plus 180 degrees is because of two zeros. Now this plus 180 degrees is because of two finite zeros. So at this particular corner frequency, there are two finite zeros because 0 will become plus 180 degrees. Again, if you want to catch or not, now this is plus 180 degrees line, again will go back to 0 degrees. Plus 180 degrees line, go back to 0 degrees means how much is added? Here it is added by plus 180 degrees. Here it is added by minus 180 degrees. Minus 180 degrees is because of two finite poles or not? Minus 180 degrees is because of two finite poles at a corner frequency. Now minus 180 degrees is because of two finite poles at a particular corner frequencies. Means based on this we can identify that two finite zeros, two finite poles. Two finite zeros, two finite poles here, two finite zeros, two finite poles here, but here one finite pole and one finite zero, wrong option. Now this is also, and there is a chance of 2, and let us take this one is also. Now there is a chance of 2 options. Is it right or wrong? But very simple. S minus 1 means S equal to plus 1. Whether it is a right side, then there is no corner frequency. Definitely this option is wrong. And only that is the correct option. But you have some doubt, not an issue. Sir, where is the corner frequency? This is the corner frequency, omega C1, omega C2. What is omega C1? Omega C1 is 10 power 0, which is equal to 1. Omega C2 is 10 power 2, which is equal to 100. Now the corner frequency time constant is inversely proportional. T1 equal to 1. T2 inversely proportional 1 by 100, 0.01. So now which is nothing but, now the transfer function g of s, which is equal to k into 1 plus s t1, t1 equal to 1. But here now there are two finite zeros whole square by, now there are two finite poles which is equal to 1 plus s t2, t2 is 0.01 whole square, which is equal to k into s plus 1 whole square by, if you take it this as common, 0.01, 0.01 means s plus 100. Now this is 0.01, 10 power minus 2 if you take it as a common. Now this is 10 power minus 4. Therefore finally the transfer function g of s, which is equal to k into 10 power 4, this is totally a k value, into s plus 1 whole square by s plus 100 whole square. Therefore, this k is nothing but, this is the correct option, A, B, C, D, and we already eliminated these two options among this, and this should be the correct option. Okay. Now the students, now we will find Bode-Platt. What is Bode-Platt? Bode-Platt is the frequency response of open loop transfer function. But what is our ultimate aim? Our ultimate aim is to find the stability or analysis of closed loop control system. So for higher orders, then it is difficult. Therefore, I can take a open loop transfer function and frequency response, and based on that, I want to answer for the closed loop control system. So that's what I'm saying. For finding the stability of the closed loop control system from the Bode-Platts or from any Platts, because the Platt which is the frequency response of open loop transfer function, but I want to answer for closed loop control system. Therefore, there is a link between this open loop and closed loop control system. Now in the previous classes we just covered now gain condition, angle condition, magnitude condition or point condition. Is it right or not? But now he is saying that here now two parameters which is called as gain margin and phase margin. Gain margin and phase margin calculations. Now he is saying that this gain margin and phase margin are the parameters which is used for finding, and these two parameters are acting as a mediator. Now this is the closed loop control system stability I want to find or analysis I want to find, but we have a open loop control system. So based on this open loop control system, frequency response is nothing but a Bode-Platt. Then I want to answer for this. Then in between these two, there is a mediator will be acting here. Now the mediators here are two, is nothing but a gain margin and phase margin. Therefore, the gain margin and phase margin are the parameters will be acting as a mediator to find the stability of the closed loop control system from this frequency response of the open loop transfer function is nothing but a Bode-Platt. Understand or not? Or a polar Platt or a Nyquist Platt or whatever it may be. So how to find that stability of the closed loop control system from the Bode-Platt or polar Platt, Nyquist Platt? Now before that, we want to answer for what is gain margin and what is phase margin, where we are calculated. Okay, but these two parameters are calculated for open loop transfer function. Here. Now first we will see the gain margin. Now the gain margin is nothing but reciprocal of magnitude of open loop transfer function. Reciprocal of magnitude of open loop transfer function at omega pc. At omega pc. What is omega pc? Omega pc is phase crossover frequency. Omega pc is nothing but phase crossover frequency. Phase crossover frequency is the frequency at which now this gain margin is calculated at open loop transfer function magnitude, but at phase crossover frequency. Now the phase crossover frequency is the frequency at which phase angle of an open loop transfer function, phase angle of an open loop transfer function which is equal to minus 180 degrees, then that particular frequency is called as phase crossover frequency. Then you catch this point or not? When phase angle is equal to plus or minus 180 degrees, then it is nothing but it satisfies the angle condition. When the angle condition is satisfied, it is not the open loop control system, it is the closed loop control system. There is a link between open loop and closed loop control system when the angle condition is satisfied. When the angle condition is satisfied, which means that it is a characteristic equation which consisting of closed loop pole, 100% it deals with the closed loop control system behavior only. Therefore, this gain margin is calculated at a valid phase crossover frequency, and a valid phase crossover frequency is coming only when the angle condition is satisfied. Whatever the frequency you are getting is not a phase crossover frequency. That phase crossover frequency, the angle must and should be minus 180 degrees. Okay. Now we'll solve a few problems you can easily understand. So if you want gain margin in terms of dB, if you want gain margin in terms of dB, which is nothing but 20 log reciprocal of magnitude of g omega at phase crossover frequency. Therefore, the gain margin in terms of dB is nothing but 1 by x power minus 1 minus 20 log magnitude of g omega at phase crossover frequency base 10. Now this is the magnitude of g omega at phase crossover frequency 1 by x power minus 1. Now this is minus 20 log magnitude of g omega. Now see here, this is a gain margin in terms of dB. Or if you remember this formula, or you can do only one thing directly. Whatever the answer is coming, that answer is applied with 20 log is directly in terms of dB. These are the formulas of gain margin. Then we'll try to find the problem. Okay, then we'll solve one problem you can understand. Now g of s, which is equal to 1 by s plus phi whole cube. This is the open loop transfer function, and he is asking to find gain margin. Now replace s equal to j omega, g of j omega, which is equal to 1 divided by 5 plus j omega whole cube. Therefore, magnitude of j omega, now 1 divided by square root of a square plus b square, 25 plus omega square whole cube. I want this magnitude at phase crossover frequency. At phase crossover frequency. Now what is phase crossover frequency? Now the phase crossover frequency is the frequency phase angle equal to minus 180 degrees. Therefore, replace s equal to j omega. Now g of j omega equal to 1 divided by 5 plus j omega whole cube. Now 1 by 5 plus j omega whole cube, which is nothing but now the phase angle denominator is minus tan inverse imaginary part by real part. Denominator is minus tan inverse imaginary part by real part, but this is 3 times. When it is equal to minus 180 degrees at a particular frequency, now that particular frequency is called as phase crossover frequency. Therefore, tan inverse omega pc by phi, which is equal to 60 degrees. Therefore, omega pc by phi, which is equal to tan 60 degrees. Therefore, the phase crossover frequency is phi root 3 radians per second. Sometimes he is asking phase crossover frequency also, and use the same procedure. So, what is the meaning of phase crossover frequency? At this particular frequency, the phase should be crosses minus 180 degrees, which means that if you observe or not, this is 0 degrees line. Now, at 0 degrees line, if you start your journey, and that phase will be crossing minus 180 degrees at a certain frequency, that particular frequency is called as phase crossover frequency. For this particular problem, I will do that one also. So when omega equal to 0, what is the phase? The phase is, now the phase equal, when omega equal 0, tan inverse 0, which is equal to 0 degrees. When omega equal to 1, what is the phase? When omega equal to, when omega equal to 5 radians per second, tan inverse 5 by 5, 1, tan inverse 1 is 45 into 3, which is nothing but minus 135 degrees, and so on and so on. When omega equal to infinity, when omega equal to infinity, tan inverse infinity is 90 into minus 3. Therefore, angle of G of j omega, which is nothing but minus 270 degrees. Therefore, now what we can understand, if your journey starts at 0 degrees and go to minus 270 degrees by crossing minus 90 degrees, and if you cross minus 180 degrees, this is the reference angle, because angle condition means minus 1 degrees. Now your phase is crossing minus 180 degrees at a particular frequency. Now that particular frequency is called as phase crossover frequency. Definitely it will crosses minus 180 degrees line, because it will go to minus 270, means it must and should cross minus 180 degrees. Therefore, this particular frequency is called as phase crossover frequency. Is existing. This is a valid phase crossover frequency. But every time you cannot draw the phase plot and you cannot see the phase is crossing minus 180 or minus 180 degrees or not. Don't check like that. Okay, if you do like that, it will take more time. No, then what should you do? Then whatever the frequency you are getting at that particular frequency and the phase is exactly minus 180 degrees or not, you can cross check, such that your calculations will be correct or not also you can easily identify. 5 root 3, 5 cancel, tan inverse root 3, 60 into minus 3, minus 1. This is a valid phase crossover frequency. Okay. So now that is the phase crossover frequency, and substitute here 1 divided by 25 plus omega pc is 5 root 3. 5 square means 25 into 3 means 75 under root whole cube, which is equal to 1 divided by root 100. What is root 100? Root 100 is 10. 10 cube, which is equal to 1 by 1000. Most of the students are go for the option 1 by 1000, because first option is 1 by 1000, which is wrong. Now what we are calculated? We are calculated only the magnitude of the open loop transfunction at phase crossover frequency. The magnitude of the open loop transfunction at phase crossover frequency is 1 by 1000. But what we want? We want a gain margin. What is the gain margin? The gain margin is the reciprocal of magnitude of open loop transfunction. This value we can get. What is this value? This value is 1 by 1000. Reciprocal of that is the gain margin. Therefore, the gain margin, which is nothing but 1000. Okay. Now, I want a gain margin in terms of dB. Now, not an issue. You can find directly. Now, I want a gain margin in terms of dB. Directly, you can substitute 20 logarithm for this final answer. Therefore, which is equal to 60 dB. Okay. Note on this. Okay. Now this is the way you can calculate that is a valid gain margin or not. But every time drawing the phase plot is not possible, no? Now we'll solve one more problem. Now G of S, which is equal to 1 by S plus 1. Replace S equal to j omega. Therefore, G of j omega, which is equal to 1 divided by 1 plus j omega. Now G of j omega, which is equal to 1 divided by square root of a square plus b square. Now 1 divided by Now this is the magnitude of open loop transformation at phase crossover frequency. Now what is the phase crossover frequency? The phase crossover frequency is the frequency 1 divided by 1 plus j omega. Now the phase angle denominator therefore minus tan inverse imaginary part by real part, which is equal to minus 180 degrees. Therefore minus minus cancel, tan inverse omega equal to 180 degrees. Therefore omega PC, which is equal to 180 degrees. Therefore omega PC, which is equal to 0 radians per second. And if you substitute the magnitude, which is equal to 1 divided by square root of 1 plus 0 square, which is equal to 1 divided by 1, which is equal to 1. And similarly the gain margin, which is equal to 1 divided by reciprocal of that, now which is equal to 1. And a gain margin in terms of dB, which is equal to, final answer is 1, 20 log 1 base 10, which is equal to 0 dB. Now the options may be in terms of 1 or options may be in terms of dB. Therefore it may be 1 as a gain margin or 0 dB. But the students, you have to be identify that this is 100% wrong. This is the wrong answer. Wrong approach. Why this is wrong? Is 100% using the same procedure, but why this is wrong? This is wrong because this phase crossover frequency itself is wrong. This is 100% a wrong judgment you are giving here. This is the wrong phase crossover frequency. Now this is the wrong phase crossover frequency. Now because that is not a valid phase crossover, I will give one small trick that whatever the answer you are getting, that answer you again substitute in the phase, then omega PC is 0. Tan inverse 0 is how much? Tell me students, tan inverse 0 is 0. But how much I want? Minus 180 degrees. Is not a valid. This is a invalid phase crossover frequency. No sir, I don't understand that. If you don't understand, see the exact one. Now when omega equal to 0 radians per second, tan inverse 0 is 0 degrees. When omega equal to 1 radians per second, tan inverse 1 is minus 45 degrees. Now omega equal to 1, tan inverse 1 is minus 40 degrees, and so on. When omega equal to infinity, tan inverse infinity is minus 90 degrees. When omega equal to infinity, tan inverse infinity is minus 90 degrees. I am substituting all the frequencies from 0 to infinity. I am substituting all the frequencies from 0 to infinity. Then the phase crossover, then the phase plot is maintained less than minus 180 degrees. If you substitute all the frequencies from 0 to infinity, but your phase is maintained less than minus 180 degrees. Whenever the phase plot is maintained less than minus 180 degrees, for all the frequencies from 0 to infinity, the phase crossover frequency does not exist. Phase crossover frequency does not exist. The phase crossover frequency does not exist, and that gain margin is invalid, and that gain margin is unbounded value. That gain margin is an unbounded and invalid, and that gain margin is not suitable to find the stability of the closed loop control system from the open loop transfer function. Students, this is very, very important. The gain margin is unbounded because that value is not a valid, because it not satisfy the angle condition. It is not satisfy angle condition. So now omega equals 0 to infinity and your phase is not maintained minus 180 degrees. Phase crossover frequency does not exist and gain margin is invalid, and gain margin is an unbounded value, and some is will treat a gain margin as infinite. Why? Because now he is taking a infinite frequency for calculating this, as treated as omega PC is infinite. What happened when omega PC is infinite? Something by infinite. What happened now? Something by infinite. Omega PC equal to infinite. Something by infinite is 0. Now magnitude is 0, reciprocal of that, something by 0, therefore which is equal to infinite. That's why this is called as gain margin is unbounded. Why you are saying that omega PC as infinite? Why you consider omega PC as infinite? Omega PC is infinite and gain margin is unbounded, infinite. Why you have to be consider this? I am considering omega PC is infinite, which means that I am thinking that at infinite frequency, at infinity frequency, there may be a chance of causing phase crossover frequency. Practically it is invalid, okay? For calculations part I am saying. For doing the calculations, omega PC is treated as infinity. Now something by infinity is 0. Now something by 0 is nothing but infinity, okay? Now all these things are not required. When phase crossover frequency does not exist, gain margin is unbounded, gain margin is infinite, and omega PC is nothing but it is not valid. It is not a valid phase crossover frequency. Note down this. That's what I'm saying, students. Whatever the answer you are getting, don't take that answer directly. Substitute that if the phase is equal to minus 180 degree, that is the valid, otherwise it is invalid. Now here, now he is given one transfer function g of s equal to k by s into s plus 2 into s plus 4. He is given one transfer function and determine the k value to get gain margin. Determine the k value to get gain margin is 20 dB. This is the question. What is the k value to get the gain margin 20 dB? Determine the k value to get the gain margin 20 dB. Now see here. Now we'll do our normal procedure. Replace s equal j omega. Now g of j omega which is equal to k by 0 plus j omega into 2 plus j omega into 4 plus j omega. Now which is equal to, now magnitude k divided by square root of a square plus b square, square root of a square plus b square, square root of a square plus b square. But I want this magnitude at phase crossover frequency. I want this magnitude at phase crossover frequency. What is the phase crossover frequency? Now the phase crossover frequency is the frequency. Now angle of j omega. Therefore g of j omega equal to k divided by 0 plus j omega, 2 plus j omega, 4 plus j omega. Now phase angle. Phase angle equal to minus 180 degrees. Angle of g omega equal to minus 180 degrees. What is angle of g omega? Minus 90 degrees minus tan inverse imaginary part by real part minus tan inverse imaginary part by real part, which is equal to minus 180 degrees. Then this particular frequency is called as phase crossover frequency. So then this is nothing but tan inverse omega pc by 2 plus tan inverse omega pc by 4, which is equal to 90 degrees. Tan inverse A plus tan inverse B. Therefore, this is nothing but tan inverse of A plus B by A, tan inverse A plus tan inverse B, tan inverse of A plus B by 1 minus AB omega PC square by 8, which is equal to 90 degrees. Tan 90 is infinity. Therefore, infinity is nothing but 1 by 0. 1 minus omega PC square by 8 equal to 0. Omega PC, which is equal to root 8 radians per second. Now this is a phase crossover frequency. The phase crossover frequency is root 8 radians per second. Then you substitute here. Now the phase crossover frequency is root 8 radians per second. Now this is nothing but the magnitude at g of j omega at phase crossover frequency is nothing but k divided by root 8. Now 4 plus 8, 12, 16 plus 8, 24. But in the question he is given gain margin in terms of dB. What is the gain margin in terms of dB? Which is nothing but 20 dB, which is equal to minus 20 log magnitude of g omega at phase crossover frequency base 10. Therefore, the magnitude of g omega at phase crossover frequency is 10 power minus 1, which is equal to 0.1. This information is available with us. Therefore, magnitude at phase crossover frequency is already given. I have this. Then this is equal to, this is equal to 0.1, then all are known to you. Only one unknown parameter is k here. So what is the k? K, which is equal to 0.1 into root 8 into root 12 into root 24 is a 4 point something is a k value. Not on this.